Today's topic is morphology of yeast, mold, and actinomycetes. So firstly, we'll discuss the significance of studying the morphology, like why do we need to study the morphology of microorganism. In the previous topic, we have discussed the morphology and role of bacteria. Today, we'll discuss about yeast, mold, and actinomycetes. So the first one is knowledge of morphology will help us in deciding the particular heat or pressure or chemical treatment to inhibit bad bacterial or harmful microorganism growth. Then will also help us in designing the process or packaging material to enhance the shelf life. Also, the idea of morphology will let us know about the harmful bacteria or disease causing bacteria. Also, for the production of probiotics or other good bacteria or yeast products, we need to know the morphology so that we can design the production based on the optimum growth levels like temperature, humidity, and all. So first, morphology of yeast. Yeast is a unicellular single-celled microorganism. It belongs to the kingdom fungi. So yeast are basically eukaryotic. That means they have a defined nucleus, but they produce by two methods, like where budding, that is formation of a bud, and then splitting, that is binary fission. So since it's a eukaryotic cell, it has a defined nucleus. Also, it has a cell wall, thick cell wall, then the cytoplasm membrane to that maintains the fluidity. It has a large amount of vacuoles present in it, and mitochondria, which is the powerhouse of cell. So types of the yeast. The most commonly used yeast is your Saccharomyces cerevisiae, that is used is in baking industry for bread production and also brewing industry for alcoholic beverages. Then one of the yeast which is harmful, commonly known, that is Candida lipolytica. It can cause spoilage in dairy products and is also pathogenic. So the role of yeast is, one is it can cause spoilage, obviously, but apart from spoilage, it has good role like for fermentation, also producing probiotics which are good for gut health. Then molds. Molds, similarly like yeast, belongs to the fungi family, but molds are multicellular. They have filamentous structure which are known as hyphae. They are thread-like structures. So in mold cell structures, they have two kinds of hyphae. One is septate hyphae, one is non-septate hyphae. Septate is cross walls, and this one non-septate are continuous, and they produce by and spores are also present, and those spores are produced by either mitosis, that is asexual reproduction, or meiosis, but that is sexual reproduction. The roles of molds is, like, the most commonly known molds are aspergillus, which produces a harmful mycotoxin that is fatal in nature or can cause paralysis. Mostly in untreated grains or nuts is present. But the one particular use of molds is in the production of penicillium, which is a well-known antibiotic. And then in food industry, it is used for enzyme production, organic acid production, but also has a risk of producing mycotoxins. Then next is actinomycetes. Actinomycetes are in nature, they are bacteria, but they have a structure similar to that of molds because of this filamentous structure, as you can see in the image. Mm. And the cell structure, as I mentioned, they have a branched hyphae that can form the substrate mycelium and aerial mycelium. One is a branched one and one is aerial one. Similarly, like fungi, they also have spores, some fungi bacteria. And Mostly, uh, they play a great role in cycling of organic matter like soil uh, and all. So the important role is it is used for the production of the antibiotic, then used in soil decomposition for breaking down organic matter. It causes food spoilage, mostly high protein food spoilage, but are also potential probiotics. So the notes, the earlier note and this notes have all been referred from the book Food Microbiology by Fraser and Westhoff. Thank you for watching the video.